Okay, good morning. Welcome to Spring. If you're interested in Spring, please have a seat. And we have a full agenda, so we need to keep on schedule. And if you're not interested in Spring, can you please continue the discussion outside? Thank you. So this is not well. This is not the usual not well. It has changed. So please read it. Since we are Friday, we'll assume that you have already read it. Minutes. So we have a Jabber scribe already. If someone wants to contribute to the minutes, it will be welcome, please. Thank you. We have a full agenda. So here it is. For your information, we had requests for 4 hours of requests, and we only have 90 minutes. So obviously the agenda is full. I'm sorry for all people which are not in the agenda. Any comment on the agenda? No, okay. So as a reminder, you don't have to wait for the meetings to discuss your draft. You can start on the mailing list, and it will also help the chairs to have an idea of how much work needs to be done in the next meeting. So please use the mailing list. So as you probably know, Martin is now working AD, so he has stepped down as chair, Spring's chair. And Rob Shakir is the new chair, so welcome, Rob. Thank you for coming. And also there is another change. The Spring AD is now Martin. And thank you to Alvaro. And my understanding is that Alvaro will keep shepherding the existing draft, which are in AD and ISG review. So thank you, Alvaro. So status report, we now have all use cases on the EP solution in RC Editor Q. So many thanks to the authors, to the shepherds, and to Alvaro again. Related to Spring conflict resolution, we started the last call and we had one outstanding issue related to consistent handling between protocols. And since this is SRMPLS specific, my understanding is that this will be covered in the SRMPLS document. So we have a slot on that today. And in this case, we will move our SR conflict draft to a dead state. In terms of MPLS Anycast segment, it's ready for last call, so we start it soon. So for the document in ISG on AD review, we have the architecture document, which is on the ISG evaluation. And we still have one discuss remaining. There is not a lot of active resolution, so if others could restart the discussion, thank you. Another one is MSDC. Again, in ISG evaluation and revised ID needed. Again, one remaining discuss. And here we are pending a reply for transport area reviewer, so I'll try to ping him again. And last one is LDP interworking. Again, AD review, we need a new ID from authors and some replies to Alvaro's comment. Thank you. Let's move to charting.
Sure. So we wanted to kind of discuss what the next steps for the working group are. The set of core documents that we've just talked through, and the ones that have already been published are now, in the ISG, or they're beyond that. So we're wanting to kind of gauge what the set of technical items to work on are, to determine what there's interest in, determine what there's willingness to put cycles into, such that we can capture these items in a charter review if we need one. We've had this discussion a couple of times. We started it at IETF 98 in Chicago, and there's been some discussion on the mailing list, of course, which we'll have seen, and now we're going to discuss it here. So we're hoping to get some input to the overall next set of work items through this meeting, and then through discussion following it. We've had a number of different areas discussed on the mailing list as bits of as potential work items. We tried here just to capture what the overall set of things are. I think that there's a few things here that we already have within the work of the working group. So SRV6 and the Yang work has existing milestones that we're working towards. So we don't really need to do anything to capture these as new work items. The other parts of this are then, it seems like there's pretty strong consensus that we should work on some OEM solutions as well as the SR policy work. As we discuss this, I think we should assume that the base state is that we work on those things, that there's agreement. What we'd like to hear from the working group is if there's disagreement, that the OEM and policy are things that we should work on. And then there's some other items in here like the service chaining work and ingress replication. There seems like there's maybe some less interest, of less people interested in working on those items. So if you strongly feel that those things are things that should be in the working group and work the technical items that we'll work on next, then I think we'd like to hear on those. So specifically on the OEM and SR policy work, is there anyone that thinks that we shouldn't, by a show of hands, be working on those in spring? Okay, 0 people. So it sounds like these are pretty clear things that we should work on. So then for the service chaining, the English replication things, are there specific support? Is there specific comments as to what exactly Spring should work on for those, and people that are prepared to work on those items? There are no comments.
I think service chaining that regards to use of SR.
Name.
Zafar Ali. Service chaining with regards to use of the segments as part of the service checkment, encoding it as part of service checkment in the overlay. So for instance, there could be SRV6 sets or SRNPLS sets. That is something that this working group should work on. There is a document on the agenda today, and that's clearly within the scope of this working group. There's a draft zoo clad.
Jim Guichard, Huawei. Excuse me, I have a cold I've picked up here, thank you. I just want to make sure that I'd like to be able to work on integration of Spring service chaining with other service chaining mechanisms. So I know it's going to require some liaison with other working groups, but definitely it's an area of interest to me, and I know to other people. So obviously my interest is the combination of Spring chaining with what we've done in the SFC working group as well. So if that could be covered, I'd be grateful.
And I agree with this. Reviewing this work across different working groups is fine, but I think that the work really should be done by this working group because the segment routing expertise here.
This is Linda Dunbar from Huawei. I think that this SD-WAN integrate with segment routing should be included in the next phase. I'll be interested in working in this domain.
Martin Vigourin, speaking as individual. Jim, question for clarification. Where are you? Yeah. Did I understand you correctly you were saying that we need some form of interworking between the different solutions that... Okay. And did you express any preference on where that work should be done?
I think it should be done.
Okay, thank you.
John Letty, Comcast. So, I think I'm interested in the piece of being able to service chain and select network paths, at the same time. So I think that work, best place to do that is really Spring and not break it up into two different working groups.
I would also like to second the SD-WAN work, which is very much related with the segment routing. The solution that is based on segment routing based architecture should be done here.
Jidong from Huawei, and I'm interested in looking on the virtualization and partitioning of the network resources. Actually, we have some draft related to this item.
Ketan Talaulikar, Cisco. On the ingress replication part, it's actually a use case or extension of the SR policy work, where the policy segments can be used to achieve this. So while this is multicast and definitely we may need to collaborate with the other working groups, it would be good to at least analyze the use case and work on it here.
Robin and Huawei from Huawei. I wanted to add additional comments about this recharter work. I think even the final the recharter work can be done to incorporate the possible item related with SR. I also worried that because there are so many working groups related with the Spring working group. So I hope that we, based on the lessons learned from past several months, I think that if some of the confliction issue is identified, I think it will be solved as soon as possible after coordination with the other working group. So that's it. That's my suggestion. Okay.
This is Zafar again. So there is some work also going on DMM working group, which is an IETF draft. Satru did mention that on the mailing list as well. I'd be interested that this working group review that work closely and work with other working group closely to get segment routing work reviewed within the working group that they are driving, but or the expertise are sitting. But the work should be closely reviewed here from an architecture and a mechanics point of view.
Hi, my name is Uma Huawei. For the morning Sutaru's email, he suggested that that work should be reviewed, and I don't think that mobility management should belong to SRv6. It should belong to DMM working group, and other proposals are there for 5G, including Lisp and ILA, and it is agnostic to data plane. It could be SRMPLS or it could be anything. So only for the SRv6 part, it can be reviewed here, but the mobility management work should belong to DMM.
I think this leads us on to a wider discussion topic that we also wanted to cover. So I think a couple of people mentioned that our existing documents have been split across multiple working groups. We've had this approach whereby we kind of do the use case documents or the overall architecture documents, and then the individual protocol working groups do extensions of them. This has resulted in a few sort of administrative things, like we've ended up with documents whereby they solely do use cases and then are not considered as a useful artifact to publish, which is, I don't think, good for the working group in general. But we wanted to solicit some feedback on how this inter-working group work should work. Should we do only protocol? Should we do all the protocol extension work in this working group? Or should we do only architectures and kind of functional specifications that give work to other working groups as to develop the solution to? We kind of have the latter case as our current approach, but there is an option to look at Spring trying to take on more of the protocol development, a bit akin to how BIA does it today. So any feedback on whether it's useful to kind of bring this work together more in Spring and avoid some of the coordination issues would be useful, I think, to the chairs.
This is Zafar Ali. I actually like the approach of taking the work here in a cohesive fashion, because it helps. The other working group should be involved in all the reviews of any protocol work that is going on here. But don't hit me. Okay, so it will facilitate the process, the review process, and also potentially accelerate the work. But I mean, certainly there's no question that the work should be reviewed by the working group, that is where the experts are sitting. But I like the approach for taking work here, protocol work here.
Justin Tiranosh, I completely disagree with previous comment, and this is the way we've been doing work in IETF, and I believe we should be doing. The protocol extension should be done in protocol working groups, and architectural documents should be done here. Lack of good coordination, solvable problem. I believe we can work on it, right?
AC Lindem speaking as co-chair of the LSR working group. We've started all the work, protocol work in the ISIS and OSPF, now LSR group, and I think it would be a real mistake to move it because it's so intertwined with the base route computation, the multi-topology, and all the signaling affects the dynamics and the efficiency of it. It would really, I think it's kind of preposterous given that we're waiting for missed refs on this working group's architecture documents. So I think that should be the focus, is finishing what is started here. If you'll note, there is really, I think there's only one document, maybe there's two now, Spring documents that have actually made it to RFC. So moving more work here doesn't seem like a good idea.
I think there's two, but you're right.
Excuse me, Jim Gishard again. I agree. Certainly from the SFC working group perspective, we've taken the approach of, we had specific architecture in mind that we were going to work on there. And I think it stifles innovation if you try and do everything in one working group. So I think it makes sense. And we've seen that with, there's work going on in MPLS, there's work going on here on service chaining that's not necessarily taking the same approach that we took. So I think it's the right thing to do to split it, the protocol work across the right working groups.
Stefan from Orange. I think getting the protocol extension in Spring could have the advantage of having all the protocol extensions for a specific use case to be standardized in a similar time frame. Rather than splitting them in multiple working groups, you could have some kind of unsynchronization. But now we can see that ISIS and OSPF have merged, so we can have a better synchronization. So the only remaining thing is BGPLS maybe. So can we put BGPLS in LSR?
Why is this relevant to be a working group? I haven't seen any relation in the adopted BIA recharter.
Sorry, we're not saying that there is a relationship between the Spring work and the BIA work. It's the model of how the BIA working group operates rather than how Spring does. So we're just comparing ways of working in the IETF, but there's no overlap between the two.
Alvaro Rutana, Routing AD. I want to first strengthen the point that I am not the responsibility for this working group anymore. I want to say that Stefan scared me because I thought he was going to say put GPLS here. So no. What I do want to say is that regardless of how this is done, the coordination still needs to exist, right? If the extensions are done here and we still need the other working groups to review, or the extensions are done there and we need to review, somehow the coordination needs to exist. And I think this is a problem that goes beyond Spring. In many charters, you have seen, because I know that all of you read everything that happens in the routing area, you see that it says, oh, this working group is going to collaborate with that other working group on A and with the other working group on B, and et cetera. This is something that we really need to get better. And maybe this is something that we need to think of specifically for when we end up with a charter here on how that coordination is going to happen, so that we can precisely, as someone else said, avoid those confusing things that have been happening over the last couple of months, right? So if we can put a specific line, and better than a delineation of what happens here and what happens somewhere else is even the coordination. So that we have the working groups talking to each other, the chairs talking to each other. That doesn't mean that we need to present the same draft in 5 different working groups at every IETF. It means actual coordination, right? Not the author walking around the IETF. So we need to better figure that out. And I'm sure that the chairs and the NeoAD and everyone else can figure that out in a way that we're all going to be happier going forward.
Short comment. So TS is not a dirty word, just so you know. There's a significant amount of work going on data modeling for SR topologies, augmenting basic topology with SR. So at the end, work here needs to plug into larger scheme of things. So interworking with TS is important, and please do consider it.
Chris Powers, Juniper Networks. I would actually support moving more towards option 2. I mean, AC referred to the delay in the segment routing based documents, but that delay was actually quite useful because there were many aspects of that were shown to be not really completely well explained in the architecture documents, and portions of those extensions were simply removed because no one really understood what purpose they served and how they were supposed to be used. So that delay could have been less had there been better coordination, had these documents either been here or elsewhere. And I see that with FlexAlgo very much to be the case.
There is one model that can accelerate some of the work, and that is if in a Spring Charter we bring in responsibility that any segment routing work that is going on, other working group, it is a Spring group responsibility to be plugged into that and review that work and sort of take ownership of that from that point of view, from just making sure that that work proceed. So, I mean, there are other working group charter that clearly state that explicitly, and maybe in the charter we can add some text in that context, and then it probably would give working group and the chair more responsibility, and that may accelerate the work that goes.
Wim Hendricks, Nokia. Oops, how is this one? I'm more of the opinion, I believe Spring should be the architectural side of things, but where there is, the strange one is actually the SRT policy, right? Because if you could say T should review it, but it's actually a BGP-based framework, and T is typically working with RSVP-based extensions, GMPLS and stuff like that. So the SR policy, which is actually the strange one here, because I believe that work should actually, it's better to be here, but reviewed with other working groups, because There is an element of SFC inside. There is an element of traffic engineering in there. There is a combination of these things. So I believe that work is better served here in this working group, but has to be reviewed with other working group from a perspective. But that protocol work, I believe, is better to be done in Spring than any other working group, given the specifics it has to Spring.
Yeah, this is Zafar. Yeah, I agree with what Wim said. I mean, essentially, T policy was a normative reference to SR architecture just a few months ago. That normative reference was removed because to proceed the document, but it's T policy work that is the SR policy work that is here. It is part of the SR architecture, and like Jim said, it actually glues many aspects like SRv6, MPLS. T is a small aspect of that, but it glues the architecture together. It is the way that we interconnect segments, which is the segment routing. So it is the heart of segment routing. So I think, yeah, proceeding that work and then having good relationship with the other working groups, so we can make sure that we drive the work and we scope the work so that we drive the work across will help.
Yeah, and I think that's what we were saying. We only really wanted to hear disagreement with that being the right approach, that we would do SRT within the policy work within this working group and coordinate with other working groups where we needed to. Okay, thank you. I think we should probably move on in the interest of time.
Okay. So next is Ahmed, I believe.
Seems like standing. Okay, my name is Ahmed Bashandi. I will be presenting. Oh, okay, that's nice. Okay, we'll be presenting an update on the segment routing instantiation over MPLS. Okay, let me just. Oh, okay, that's much nicer. Okay. So the purpose of this draft, as many of you have known, is to specify how to instantiate the segment routing architecture over the MPLS forwarding plane. The key modification in this version is to address the area director reviews, and thank you very much for the detailed review. And to the second part, which is incoming labeled collision, which is related but not identical to the conflict resolution. So I have already sent an update about the AD review comments a couple of weeks back, but I will go over them quickly. So why is this document a standard track? We're specifying many externally visible behavior that we need to make sure that all routers follow. The term SRLB, we address this in detail. The term index and how to use the index to compute a label, I think we addressed this in detail. IPR declaration, I will go over them one more time and see if there is anything that is relevant to the segment routing architecture, and we'll just make it clear.
Albert on routing ID. How many people here read my review? Okay, I mean, I don't know how, what you want to do with that list, if you expect me or someone else to say, good. But, just so that everyone knows, yes, I made comments, all those comments. The draft has been revised, where now it is double the size.
That's fine.
And
that's fine.
I'm not saying it's a bad thing. Now it's double the size. Most of it to answer some of those questions, especially the first one. And I returned it to the working group. So the important thing here, I think, is that now this work is part of the working group again. So sure, I would love for you to resolve my comments, but you fundamentally have a different document than when I first read it. And more importantly, even if you address all that, the working group still has to last call, and now Martin has to go review it and everything else again. So yeah.
Yeah, sure. I'm just giving an update. This is an update about what is the purpose of this version. And I'm just listing them here. That's why it's just one slide, and I'm not putting any details here. I'm just saying it's addressed where. Go ahead and look up the review, the email that I sent a couple of weeks back. So what's a valid sRGB? This was replied to, next hop, so on. There are a few terms that we removed and we agree they are not very necessary. There are other minor comments which I encourage people to look at the mailing list or just read the email reply. The next big thing is the incoming label collision, and the objective of the label collision, first of all, is simplicity. We want to make this simple. We don't want to over-engineer it. We want to make it routing protocol independent. If there is anything that needs to be done in the routing protocol, it should not be sitting here. This is routing protocol specifics. Objective is to guarantee consistent FIB. There is no global consistency. I cannot do it. If I want to ruin the network, I can always do that. So Chris, you have a question?
Well, so it was on your previous slide. You said you've done, I think, 3 IPR declarations.
If I remember things correctly, it has been a long while.
Okay, but you say you do more if necessary.
If necessary, I'll just have to. I didn't have the time to review the IPRs done on the Spring segment routing to see if they are applicable. Then we'll just make them.
Okay. So, so you're still doing evaluation about what more needs to be done, because we're not in a position to evaluate that.
Correct.
What you need. Okay, I just want
That's
to make
one
sure
of the comments, important comments that Alvaro gave, and we certainly will address them.
Alvaro Routing again. So just to be clear, because I don't think maybe I didn't explain myself very well when I did my review. I'm going to be blunt, so I'm going to apologize. When I read the draft the first time, I thought the draft said nothing. That's why I asked why it was even on the center track. And everything that I thought the draft said actually was already somewhere else, like the architecture document. And so the reason I brought up the IPR question was because this draft, the MPLS draft, has IPR against it. I can't judge whether it's good or bad, but because it didn't say anything, right? I was surprised that it had IPR when the architecture document doesn't. So my question was not about, did you file everything? My question was, are you sure you had to file against this draft and not something else? Because again, the IPR doesn't have, or the architecture, sorry, doesn't have IPR against it, if I remember correctly. But this draft, when I reviewed it, it reflected very much the same thing as the architecture document, that it had IPR. So it just surprised me that not did you file everything, but did you file it against the right one? And I know that this draft has gone through a lot of changes since the beginning. So maybe at the very beginning, it reflected something else. And maybe that's what you added back again. I don't know. But my point is that was the question. It wasn't whether you had more or, et cetera, but really whether it was against the right one.
Okay. Thanks for the clarification. And as you mentioned, it changed. And as you mentioned, also doubled in size. So probably now the IPR that we made against this will be relevant, but I will still look at the IPR to see if there is anything that is even a little bit relevant, and we'll make it. So we do not guarantee, I go back to the incoming label collision, there is no guarantee to domain-wide consistency. As I said, if I want to ruin the network, I can always configure a static route that points to me and from me to the other guy. And there is no way we can do it. So the idea is basically we define what is called an SR-FEC. An SR-FEC, just a good old-fashioned MPLS FEC that is related to segment routing. We just need to define this so that people can read through the document. Basic MPLS, common sense, a label is assigned to a single FEC. Others, they can have other labels. They don't go without labels at all. That's a different story. Okay.
Greg Merskiziti. So are you suggesting to create another FEC in addition to ones defined in LSP ping for segment routing?
I am not sure what you mean by other FEC, but the definition of FEC is the set of packets that gets forwarded in the same way, and this is defined here. I'm not sure what you mean by another FEC.
There are FECs defined in LSP ping for segment routing over MPLS.
I am not sure define other FECs.
It's RFC now.
Yeah, no, and this document does not define any new formal FEC. I think that he's using this terminology just loosely. Okay. No new FEC is being defined for MPLS or for LSP ping.
So we abstract all control plane things, be it static, be it configuration, be it routing protocol, as what we call MPLS control plane client. We use the same term in the segment routing to LDP interoperability. Is basically anything that downloads a FIB entry. Tie-breaking rules are very simple. Each MCC within its own self will give me a FAC, an adjacency SID, and a label. An adjacency SID is defined as an outgoing interface and a next hop. And it will give me a label. This will be received by either the FIB and the RIB. If it sees the same label assigned to multiple FACs, it will basically pick one of them only, and the others will either get dropped, get downloaded. This is not really within this document because this document talks about MPLS, or instantiation of segment routing over MPLS. Important thing is that they are deterministic rules, which means first come, first serve is no good. If you have the same set of adjacency SIDs competing for the same label, then that adjacency SID will always get picked. Or if I have a prefix SID and an adjacency SID competing for the same label, which shouldn't happen really, then let's say I will always pick the prefix SID. The tie-breaking rules are basically quite simple. As we've been doing with routing protocol for ages, each FAC or each cross-connect or each set of packets that gets forwarded the same way that they are assigned an admin distance. We pick the one with the smallest admin distance. If there are still competing FACs, you just pick the one with the smallest numerical value. As simple as that. As I said, objective is not to guarantee domain-wide consistency. The last thing that we spoke about, and I got some comments after I published the draft, so I will incorporate them. Redistribution. If two MCCs give a prefix and a prefix SID index to each other, then the receiving MCC, be it, let's say I am redistributing from OSPF to ISIS, the receiving entity, which in this case ISIS, will only advertise this index that it got from OSPF if the sRGB are the same. If the sRGB are different, it is free to assign a new SID index, provided that it downloads the corresponding label to the FIB, or it advertises it without an index at all, and it may get assigned through some other mechanism, for example, either uses LDP label or relies on some mapping server. That's pretty much it. Any questions? So, how many read the document? Okay. Okay.
I think given the changes that were in this version, especially the sort of absorption of the conflict resolution draft, it would be definitely good to get the working group to review this. We probably need to go around another cycle of making sure that it's stable, but this should really be one of our top priorities.
Yes.
I think this doc has been around for a long time and exists, and we need to stabilize it and get it published, I think.
Totally agree. There are a lot of protocols that are based on this, so we really need to stabilize this and make sure that it is perfect. This way, all other routing protocols are basically also stable. And thank you very much.
Ketan?
Hi, Ketan Talaulikar, Cisco, presenting on behalf of all the co-authors. I'm going to keep it very brief because we are very short on time. The segment routing architecture has defined multiple segment types and how they have to be used and all of that. What this document does, it introduces the notion of SR policy, which is something that can be set up or instantiated on a node. And that actually results in a stack of segments being encoded into the packet, on that router when going through. this notion of SR policies, as we discussed earlier in the group, it has wide applicability. It applies to both MPLS and SRv6 data planes. It has traffic engineering, but also NFV, some layer 2. There is a separate draft for optical and multicast. So it has a wide applicability. One of the key things that is defined here is in the draft is also the steering. So how are packets actually steered onto this SR policy, or how is that stack of segments associated or imposed on that? And it also covers some traffic accounting parts. Just at a very high level, what are the key attributes? It's for both MPLS and SRv6 data planes. The key thing here is the state is only on the head-end node. It's not, all over the fabric for a particular policy. It does not have to be hop by hop or like a circuit kind of a thing. It tries to leverage IP, ECMP, and those attributes. The segments can be a mix of topological or service segments. There are different types of segments which are covered in the draft. These policies could be instantiated automatically or provisioned via controller. There are multiple protocol options, BGP, SRT, PSEP to do this. And the draft also talks about some use cases where there is this integration of the overlay services and automated steering mechanisms for it using the SR policy construct for it. So it is an integration of multiple segment types here. Binding SID is a key concept that is introduced and perhaps defined more formally in this document. It provides scaling, kind of opacity. It's really the key forwarding entry, key to the forwarding entry for the SR policy. The draft talks much more detail about its allocation, various options, and so on and so forth. Very quick on the steering things. These are all detailed more in the draft, so I wouldn't go over it. But at a high level, one simple, straightforward way is steering using the binding SID. But then there are other mechanisms like per destination steering, per flow steering, automated steering for, let's say, BGP routes as they come or as they signaled. The SR policy for them is automatically computed and instantiated. These mechanisms have been there in the draft from the very initial version. The further revisions have addressed comments and clarified them in more details. The draft was first presented a year ago. Since then, there have been several contributions from multiple vendors and operators. So it has been updated with a lot of clarifications and details following those reviews. There are existing implementations from multiple vendors. Some of them are still in progress, and also there are deployments and trials ongoing. So it's really key work that we are doing here in Spring. In the interest of time, not going into all the details, but what we would like to do is ask the working group to review it more, and we can discuss on the mailing list feedback. But at this point, the authors would also like to request the working group to adopt this draft as well. Any questions?
Robin from Huawei. In fact, in the routing area, when every time talk about the policy, definitely is very complex. So I think that is for the SR policy. In fact, is not only the steering policy, but also the tunnel setup policy and the binding allocation. So I think this work is useful, but I worried about the scope of this work, because I think now that it seems that another draft is proposed related with the BFD policy is added to the SR policy. So I think for the past years, so that's we also have a lot of policies related with the tunnel and the policy related with the traffic steering. So I worried about that's just my worry. The scope may be hard to be controlled. So I hope that it can be clear defined in the document. That's my concern.
Right. So we've had this stack, this notion in segment routing of the stack of labels, right? But how does a node define what does that mean? And as we have discussed, each segment could mean different type. We have segments for all kinds of things. So the SR policy, what it means and what it involves is what's specified or described in the document. So it's not just a term out there. Now, what are the use cases for it? I agree, maybe there are many more use cases. The draft talks about some of them, but I don't think it's like a use case document in that sense. I think it's for the working group to see how the use cases go, but it's more formally trying to define the notion and how it can be instantiated. There could be more about it, yes. The protocol things, the BFD and those aspects, that's I think covered in separate drafts that we have coming up later in the agenda. I don't know if that addressed the question.
Yeah, I agree. I think this provide a baseline, and there's some, like Ketan said, there's other documents that are building on it. So it would be in working group interest that where we actually adopt this document, start working on it, so the other drafts can proceed. That would rely on this.
Yeah, there's a separate document which talks about optical segments, and there is, all those are more detailed use cases about this. This is just the basic framework about that.
I think we do need to agree what should go into this doc versus other things, though. It's a very long draft right now. It covers a bunch of diverse things. So I think as we have this discussion around policies, ensuring that we understand this document tells you about this and is addressable for that reason, and then we split out additional documents, and working out what the set of documents the working group should produce is quite important.
Yeah, definitely. I think we should discuss this more on the mailing list and see how to.
Also, policy is a wide term, so maybe you can scope it at the beginning of the document.
Sure.
Next, François. Okay. Okay, sorry.
So my name is François Claude, Cisco. I'm going to present this draft segment routing for service training. This is an update since previous revision have been submitted before. And thanks. So the agenda is quite straightforward. I will summarize the changes since the last revision, remind the base aspects, the base concept described in the document, and also give an update on where we are in terms of implementation, particular open source implementation of the various concepts described in the draft. The most important change in this version is that we are actually merging two drafts that have been presented. In the previous IETF, both have been presented in Singapore. The first one was more focused on the MPLS aspects of service training for segment routing, while the second one was segment routing neutral and described some proxy behaviors to support segment routing incapable or unaware services. We also aligned the terminology with the segment routing architecture document, so the SR draft and also the SR policy draft. And we added a table at the end of the document for the new SR-v6 endpoint types that are covered in this draft. So first, for the SR MPLS aspect, an SR MPLS service segment is an SID allocated on a segment routing MPLS router that is connected to the service. There are two different flavors for such a service segment. Either it can send the packet with the MPLS label stack to the service, acting somehow as an adjacency segment, or it can implement a proxy function in case the service is not capable of processing a packet that has a label stack on top of it. And such SR-MPLS service segment can be allocated from the local or the global label pool, depending really on the use case. We believe that it is more practical in most cases to have a local SID, a local label. But there could be some other use cases that could benefit from having a global label. So we do not want to mandate one or the other. For segment routing v6, it's quite similar. One option is to have the SID instantiated on a router or an SR-v6 capable host that is connected to the service, and that will either send the packet with the segment routing header to an SR-v6 capable device, or we could use a proxy function that is similar to the MPLS proxy function to remove or to hide the segment routing header before sending the packet to the SR-v6 unaware service. Another option that is new with SR-v6, that is enabled by SR-v6, is to have really a segment routing aware service that will have its own local SID table. So its own list of segment, and could have different behavior depending on the active segment in the packet that it receives. It could also, such a segment routing v6 aware service could also read some additional information in the segment routing header, such as the TLVs, the tag, or other information. Now, how does the service segment integrate within the segment routing architecture? It's quite simple, actually. The service segments are just another type of segment. And as such, it inherits all the same properties of the classic segment routing SID or segments. It is stateless. The service segment can be integrated with other types of segments, such as VPN or traffic engineering segment in the same segment list. And also, one important thing is that it is opaque to the head end and the intermediate nodes. The head end will just push a list of segments onto the packet, either via an SRH for SR-v6 or an MPLS label stack. And I believe we have a question.
Yes, hi, Greg Mirsky, ZT. So when you characterize as a stateless, you mean that segment nodes that host service functions don't have idea where the next hop is. So you expect to program the whole service function chain with services from the head end?
Yes, exactly. Yes, the whole service chain is programmed from the head end.
I'm sure that it will scale, because the idea of NSH, in architecture of NSH, that SFF resolves the next hop, and that's instantiated in a control plane. So you do define the service function, but by identifying the service chain. And then each SFF has notion of where the next hop for this service function chain is.
Yeah, in that case, the whole service chain will be defined from the head end as a list of segments, possibly computed by a controller. So when the packet arrives at the head end, if the head end doesn't have a route for for the BGP next hop, with the example of BGP, it can use mechanisms such as on-demand next hop that have been defined for the SR policy to query a controller that will reply with a seed list encoding the service chain.
Okay, so basically you exclude the case when you have classifiers within the service chain, so to do reclassification based on the service function results.
No, it's really the head end that is the classifier.
Okay, so only one classifier. Okay, thank you.
Just one more small comment. I think actually that approach is more scalable because we really don't have to put anything in the core or at the SFFs. It's basically everything at the head end can calculate with an outer PC or controller and simplifies things.
Hi, this is Zafar. I echo what Ahmed and Brad said. I exactly came in for that same comment.
So Jungisha obviously have a different opinion, but I don't want to talk about that specifically. My question is, it's actually a question on the proxy function and a clarification.
Yeah.
I just want to make sure if my understanding of the draft is correct. On the proxy function, you need a separate interface, whether it be a sub-interface or a VLAN or whatever it is, per segment path. Is that correct?
Yes, we need a separate interface as it is described today for each service chain or for each segment list.
Right.
In the future, we may have some other type of kind of reclassification on the proxies, but this is just a basic behavior to start with, and obviously it can be extended if needed.
Yeah. The second question is, do you take care of the cases where, like some of the pictures that I saw were kind of were simplistic pictures. It's an SFF to an SF, but in reality, you could have multiple instances of these service functions hanging off the same forwarder.
Yeah.
So, and I want to be able to load balance my traffic across and pick a particular instance. So when you do the proxy function, what that means is that you're actually, if I've got 1,000 paths, then I need 1,000 sub-interfaces per service. Now it becomes really unworkable. So one of the options here, and I'm not going to talk about my own documents, but there is an opportunity here to integrate this work with the work that we've done on NSH, because NSH has the capability to identify based on a path ID. And then you can just use the path ID coming back from the service to indicate which segment stack to push back on the packet, and you don't need any of these interfaces. So it's just something to think about.
Yeah, if you need a proxy and if you use one of the proxy mechanisms described in the draft, you may have some scalability issues if a lot of service function instances are behind the same router or service function forwarder. It's kind of the same in our segment routing architecture. But that only applies if you need a proxy, and otherwise you can just have it specified from the head end, and the head end will decide which instance to pick. And will load balance.
My only concern is that we've spent the last 4 years trying to persuade service vendors to implement an encapsulation to do chaining. And now what we're going to do is ask them to implement yet another encapsulation, which, by the way, in 4 years, by the time they get to it, there'll be another encapsulation.
What?
So what I'm trying to say is, let's reuse what we actually have so we can actually separate the problem. There's the forwarding element to it, but then there's the service plane element to it. And the service vendors are interested in the service plane element. They don't care about the forwarding aspect. So that's why it's important maybe that we can integrate with some other work that we've already done in IETF. That's
sure. And I think it would be interesting to discuss this aspect.
Okay.
Hi, Alan Shalik. Just very briefly on your single classification, just to point out that if you have multiple services, you can get an explosion in your classification space if you have to do a cross product across all the classifications each service wanted. And then subsequent to that, if any of those services happen to modify the packet in a way that the initial classifier can't predict, then your initial classification begins to fall down as well.
That will really depend on the proxy implementation. If you use a proxy, if you don't use a proxy, then you don't need to reclassify anything. So I guess we are fine at intermediate segments. So now, yeah, it's the penultimate slide, and I will be very fast. So in terms of implementation, we have some implementation of the proxy functions that are open source in Linux using the SRX kernel module, and also in fd.io VPP. And we now have also some very well-known and used services that are segment routing v6 capable, which are IP tables, NF tables. And in the case of these two, the segment routing capability is even in mainstream, so it's supported today, really. And Snort is coming as well. The patch is ready. It's not mainstream yet, but it will be coming. And the next step is really to seek working group input and feedback. If you have any question, any comment, suggestion on how to improve this draft, please let me know.
Thanks.
Thanks. Thank you.
Okay, hello everyone. I'm Kamran Raza. I'm presenting this draft SRv6 YAG model for base and static. Just a very quick history of this draft. This was 00 version posted last IETF, and this is version 01, which merges two drafts. This draft Raza for SRv6 YAG and draft Hu from Huawei. So this is the one combined draft that I'm presenting now. Okay, so this is kind of companion document or companion YAG model for the SRv6 network programming document. So familiar with this document is must needed in order to understand this YAG model defined. So overview of the YAG that we have, this model basically defines two things. One is a base model for SRv6 segment routing, as well as a static application that you could use to configure static sets or static endpoint behavior. In the base model, basically, it defines procedures and configuration leaves for managing your SRv6 subsystem, as well as we expect that this base model that we have defined here will be extended by the relevant technology models which are already in works for SRv6 area for ISIS, BGP, service function chaining, and whatnot. So it defines three modules really in this specification. The types model, which is a common definition for SRv6 constructs. The base model, which defines the base items to configure as well as to display states for a given SRv6 subsystem, and a static model. So in the base, these are the base items from SRv6 network programming document that this YAG model defines, and we expect this to be reused and applied in other YAG models as we go further. In the base config model, what we really have is a simple thing that how do you enable segment routing, what different parameters you specify for the data plane for encapsulation, TTL propagation, in future perhaps some QS items as well. As well as the fundamental piece for the YAG for SRv6 is a locator. So how do you specify a locator, and how do you enable it? So that's a base config. With the base config, there's a state model for the base as well, which really captures three main things: the state for the node capabilities, for the locator, as well as local SID. Node capabilities just basically tells you what this node can do about SRv6, different type of end functions it can support, signal parameter which IGPs will signal for SRv6 capabilities, as well as different rules and counters that a given platform or hardware could support. So this is just the state for the node. State for the locator is simple, but I think most interesting is state for a given SID. So you can have a state for a given SID, how this SID is allocated, what are the endpoint behavior, how it is being forwarded, path structure for the forwarding, as well as a per SID counter or aggregate counters are defined at this point in time. So I'm going fast because we are late and I have only 5 minutes. This module also defines base notification. There are only 2 of them defined right now. Probably there will be room for more, and we will extend as we go along and we find the use cases. So this basically concludes what the base defines. The second part of the document is a static application for SRv6. Currently, it defines how you can configure a local SID using a static manner, and different type of endpoint behaviors you can use. And then, as SID, of course, you have to use forwarding construct in order to not only allocate, but also forward traffic on your local SID. So it defines a construct to allow you configure a local SID and also specify encapsulations. And encapsulation could be SRv6 or could be MPLS. If you just to recall, n.bm allows you to have a SRv6 local SID, but forward on MPLS labels. So just to conclude, next step for this draft, we have a couple of pending items which we have captured in section 5, QS things, argument support in our model, and more end function support in our static model. So we will address in the future revisions. At this point in time, we are just seeking for working group input and feedback on this draft. I'd like to, if you have any questions or comments, please go ahead.
I don't think we have time for questions.
Yeah, so I was fast enough?
Yes.
All right. All right, thank you very much.
You win the words per minute prize for today. That's fine.
All right, thanks.
Zafar, thank you.
Hi, my name is Zafar Ali. I'm presenting this draft on base of one of my co-authors from different service providers. Next page. Yeah. So when we started this work, the very first thing that was a reality that SRv6 network would be sitting alongside classic IPv6. So you would have nodes that would be SRv6 capable, and you will have nodes that are IPv6 capable. And we want to start with something base that can work in a mixed network in various interworking scenarios as we start to roll SRv6. Now, one of the things that this draft starts with a classic ping, and then it starts to go into something like ping via SID list. So it is, main point is that it's relying on ICMPv6 for that purpose, so that the classic nodes can operate seamlessly. So you don't have to upgrade the classic node, whether that classic node being the destination node or that classic node being a transit classic node. It will just work seamlessly for those. And same thing applies for traceroute. So this would be like a classic traceroute that we use with SRH inserted, so the packet can route through the route that we want the packet to go through, or we think the packet should be going through. But if we have a classic node, TTL expiring of a classic node, it will work seamlessly. It would not know the rest. So the only changes that we would really need is not the transit node, not the destination node, but the ingress node, which knows that it is trying to construct a trace route or a ping via a SID list. Now, and then it goes into about something like ICMP ping. If you are going to a destination and you're trying to ping a SID on a remote node, and in that case, you need to define a behavior which is punt behavior at the remote node. So one of the things that in the punt behavior that we need is a SID, which is in this, we define a SID behavior in the network programming document and that's an n.otp SID. And the construct for the n.otp SID is that you can actually have that SID in the SRH and have the target node punt the packet for further processing. So in this case, the target node is the destination node where the A4::, DC45 SID is implemented. So you put the n.otp SID ahead of the target SID, and that makes the target node punt the packet and send the response back. For trace route,
Zafar, you have 60 seconds
oh,
left.
Okay.
Thank you.
Okay, so we have two flavor of trace route. We can do hop by hop.
Maybe you can skip to the conclusion.
Yeah. I just do this and then. So for hop by hop trace route, it's business as usual. All the node hop by hop based on TTL expiry will respond to this trace route. And there's another flavor which is there's the definition of OBID in network programming document that can help us to implement some flavors like proof of transit, which is described in the document. And because in the interest of time, I'll go fast here. And then based on the construct of n.otp SID and the OBID, we can have flavors like hop by hop trace route, which will trace both the SRVC cable node as well as the classic MPLS node, and the overlay trace route that will skip through all the nodes that are not part of the SRH and will only basically traverse the node that are part of the SRH in the SID list. With that in mind, we would like to actually ask the working group for more feedback. We need to work more on it. This is a starting point for the work. I think it'd be too early to talk about anything like working group adaptation, but if you want to, it's fine.
I think we should discuss it on the list. Sam, do you have a 10-second question or
sure.
less?
Couple of scope questions. Is there this Sam from Google? Is there a way you can determine MTU or MRU? And the second question is the scope captures where you have non-SR, whatever you call the green node in the front, and still do the SROAM?
Yeah. So the scope is non-SR node for sure. And for the MTU, I take it offline, probably best. Thank you. Thank you.
Thank you. So this is for SR MPLS. We have BFD 5884, which defines BFD asynchronous mode over MPLS LSP, and that it could be applicable to SR MPLS. It should use LSP ping, and now we have SR LSP ping for SR MPLS defined. So the requirement that about the BFD control packet encapsulation can be IP or ACH encapsulation. The problem that might be exist here is a similar problem, same as with their generic traffic engineering path, that their path that being monitored from the ingress of BFD session is disjoint from the return path of the BFD session from the egress to ingress. So thus, failure on the reverse path may be seen by the ingress as a failure of the path that being monitored, because node B in this diagram will report it as a failure in a diag mode. So in order to minimize this possible false negative, it's good to control the reverse path. The reverse path can be controlled using extensions to LSP ping that's defined in MPLS working group document BFD directed, or it could be done using non-FAC element that explicitly lists SIDs that should be used for the reverse path. Another alternative to controlling the reverse path could be to use BFD demand mode. The nice feature of BFD demand mode that it could be done on and off dynamically, and the node that is put in demand mode would not be sending periodic BFD packets. So thus, in its construct that we consider, with a traffic engineered path unidirectional being monitored, node A and B can bring BFD session to the up state, and then ingress puts egress in a demand mode. Thus, B ceases to send periodic messages. But B node can send messages with a poll bit set that changes its status, namely when it detects the failure from A. So this is covered in BFD over MPLS demand mode, which is in its individual draft in BFD working group. So this is just shows there everything. So that's all. Do I have time for one question?
Yep.
Thank you.
Sam from Google. Is anic acid in scope for BFD? If so, please document that.
Okay, thank you.
Next is Zafar. No more than 5 minutes.
Okay, so this is the work that talks about looking into some of the requirements. I start by looking at some of the requirements in terms of the SR policies. And when we are trying to run BFD session on top of the SR policies, what sort of consideration we need to make. So few things. One thing that the SR policies does not require any hop by hop signaling or any signaling mechanism. So the previous mechanism, like the, for instance, a bootstrapping BFD session, really, we do not have luxury for doing something like that. Second is that SR policy states by fundamental design are only and only at the head end, the ingress node. No other node in the network has those states. So for BFD over SR policy, we should not be creating a state at the tail end of the policy. So that's one of the requirements. Other thing is that in many deployment scenarios, or most of the deployment scenarios, the BFD, the SR policies are instantiated on demand basis, like ODN use case, which means that the mechanism for BFD has to be fast because the policy, before it starts to send the packet onto the policy, the ingress node like to verify if I have data plane connectivity. So whatever time we take for bootstrapping BFD or anything has to be minimized. It has to be fast session progress. And it has to cover both MPLS and SRv6 data plane because the policy's scope is equally applicable to MPLS and IPv6 data planes. So when we look at from this angle, like we're going to look at the classic BFD and also SBFD. So classic BFD has the issue of bootstrapping the session on the remote end, and it will slow down the process, and then we don't have any signaling mechanics to do that. So there are two issues. Second part is that is bidirectional by design. So you have BFD states on the tail end of the router, which SR policy does not have any state associated with the tail end. So if we start to use classic BFD for SR policies, we will end up creating states at the tail end for the purpose of BFD, which is not desirable. Second part, let's look at SBFD from that perspective. So SBFD is faster in terms of session activation, and because we don't have to bootstrap anything, and then second part is that it does not create any state at the tail end. So tail would be completely stateless for the BFD, which is the desirable goal for the SR policy architecture. So the statement in this informational draft at the moment is that SBFD is more suitable in terms of use for the SR policies than classic BFD. So we'd like to get some feedback. Greg, go ahead.
Yeah, Greg Mirsky, ZT. So as you saw, as was in the previous presentation, if you have traffic engineered SR,
then you cannot guarantee that your forward and reverse path of SBFD session are corrupted. And thus, if IP network that you return your SBFD packet fails and doesn't converge with your detection time, you will have false negative. Another thing is that we will be bringing, we try to bring it to this meeting, but agenda was to fill full discussion of bidirectional SR tunnels. So for the bidirectional SR tunnels, SBFD is very ill-suited.
Yeah, so I think this is fair. I think the first comment regarding return path, not having a return path towards the source, we should discuss more offline, because so I think let's discuss that offline. And for the bidirectional policies, we did not scope it in this work, but we can discuss that offline and talk more about it and have it here. Thanks.
G?
Okay, so I'm going to talk about how to use segment routing to support this enhanced VPN service. Okay, here's the motivation. We know that VPN has been widely deployed to support multi-tenancy service in the operators' networks. But recently, we are facing the new and emerging services which have more stringent isolation and performance requirements, such as bandwidth, latency, jitter on the shared network. And I think Stuart has given a presentation about the framework of the enhanced VPN in the RTGWD yesterday. Basically, the enhanced VPN is aimed to enable the multiple customers with demanding service in the shared network. And also, it can ensure that high performance with a reasonable and scalability. Also, as we're talking about 5G, we think it can be, although this technology, this mechanism can be in general useful for in the 5G context. It can be used as an underpin for the network slicing. But it should be noted that it is not our goal to totally replace its existing VPN service, because we should try to reuse existing technology as much as possible if it is good enough for the service. But the purpose here is to design a new service for the high demand on isolation and performance for that kind of customer or service. So let's take a look at the existing VPNs. We can go through it quickly. The overlay VPN, basically this has very limited requirement on the underlay, as the underlay just provides the connectivity, and this kind of service that can provide the isolation in the address space and the routing or forwarding tables. But this kind of services of different customers, they will share the network resource in the network. So this will result in the uncertainty in the performance. Another service is the VPNs can be deployed with the TLSP as the underlay. The TLSP can provide a purpose traffic engineering and also can improve the resiliency with the TFRR. But usually the TLSPs are shared in the network by multiple services or multiple VPNs, so that it cannot provide isolation between the customers. And due to the scalability issue, it is not widely accepted to deploy the per VPN service dedicated TLSP in the network. And now we have the segment routing. We can use segment routing as the underlay for the VPNs. Where it is well known that the segment routing can have many benefits, like can have less protocols and less state to maintain in the network, and it can support flexible service path programmability. But we can see that currently the segment routing, they're using the shared seed in the forwarding plane, which indicates that there's different services that will share the resources in the network in the data plane. So what is the enhanced VPN? So we think the principle here is that it will provide a tighter integration between the overlay VPN and the underlay network resources. We think this characteristic is independent of the overlay VPN signaling, so it will apply to all these VPN types, like layer 3 VPN, layer 2 VPN, EVPN. And we believe in order to achieve this kind of enhancement, some technology innovation in the forwarding plane will be needed, because there will be the build foundation for the unguaranteed natural resource for each VPN service. And please refer to the technologies mentioned in the framework document. By the way, we need to mention that this draft will be moved to TIS working group later. And once we have this enhancement in the data plane, how about the control plane? Basically, the control plane should provide the capability to create a customized virtual network with dedicated network resource. And this control plane should be agnostic to the specific forwarding plane technology used to guarantee the resource. And although we think that the number of the enhanced VPN will be much less than the existing traditional VPN service, still we should consider the scalability in the beginning. So the segment routing with resource reservation, we think currently this segment routing to provide the network virtualization resource partition is covered in the current charter, but still we think the current SRNet technology does not fully support this resource reservation, because services passing through the same links or nodes will share the resource in the data plane. This will cause the resource contention due to the nature of the IP traffic, like the traffic burst, etc. So we need to extend the segment routing to support this kind of resource reservation or resource partitioning. Basically, the mechanism is to do it in a topology aggregated resource reservation, so that it still comply to the segment routing paradigm. There's still no per pass or per flow state introduced to the network. And what we do is on each network segment, we will allocate different segment seeds to represent different partitions of the resource on this segment allocated for each different topology. And then a group of the seeds associated with the same topology can be used to construct a segment routing virtual network with the resource in the underlay. Then we can map the VPN services to the dedicated segment routing virtual network. Depends on the service requirement. It can be very flexible. You can do it one by one, one-to-one mapping, or M-to-1 mapping. This depends on the requirement of the service isolation and performance. So here's an example about how to do the seed allocation in this approach. We can see in this network, we can use dedicated seeds to represent partitioned link or node resources. And the seeds in the same color, they represent the seeds used in the same topology. They will be used to construct the isolated virtual network. And this kind of different virtual networks, they are truly isolated in the data plane. And this shows how this packet of different enhanced VPN are treated in the data plane. Basically, we can see that different enhanced VPN, the service paths of the different enhanced VPN will be constrained to its own virtual network topology, and so it will only consume its own resources reserved in the network. It can support the strict path forwarding and also the loose path forwarding. Okay, here's the overall procedures of this mechanism. I think I don't need to go through the details. Basically, we need a controller on the top to do the topology and the resource computation. Then we need to do the topology resource allocation in each network element in the network. And then we need to advertise the seeds and the associated resource information in the network so that each node is aware of this topology virtual networks. Finally, we bind the VPN service to these virtual networks to achieve this enhanced VPN.
Just as clarification, and I clarified this when the presentation was done at routing working group. While talking about resource reservation, you're actually talking about extending past computation logic on the controller to be topology aware. There's no resource reservation in segment routing whatsoever.
You mean currently, right?
Yeah, so I think it's important. Otherwise, your slide's kind of misleading. You don't introduce resource reservations in segment routing. And this is what slide said.
We need to do it both in the controller and also in the data plane. It's but it's not by the hop-by-hop signaling.
You really need to explain yourself. We know how we do resource reservation with RSVP. You go.
Yes, we are not
You're
using
not doing
the
this.
RSVP approach.
And so please explain yourselves.
Yeah, I think this we can see this picture. Basically, you use for example, on the one link we have 3 seeds. Each seed actually represents a partition resource on this link. So you need to allocate a particular resource in the data plane for this link for this seed. And another seed on the same link will represent another portion of the resource on this link. So they are isolated and both in the control plane and also in the data plane.
I think Jeff's point is that you want to partition resource in the network, but the reservation itself is in the PC or controller. Yeah.
Yeah, it should be done by the PC controller.
Yes, but not by Spring.
Not by
Spring.
Yeah, we need to allocate to different seeds.
Yeah, sure. You want to partition in Spring?
In Spring, in the data plane?
But allocation is to be done in a PC or...
Yeah, allocation is done in the PC.
Okay.
Ketan Talaulikar, Cisco. We discussed this draft offline, but I would like to echo what Jeff said. Whatever has been presented in this slide, all these things are not there really explained in the draft, the exact mechanisms. So I think the draft needs all this clarification. And I'm also confused about where exactly and how these resources are reserved and how it is done. The draft currently does not clarify. Yeah. So I think it's important that you describe and put all those things so that Spring Working Group can review it, because the concept is, bringing reservation in the network and setting up is a very important change. Right? And final thing is, this is called a standard stack draft, so we need to review it even more carefully.
Okay, I think we will add more details about the procedure in next version.
Zafar Ali. One comment is that the requirement that you have can be met with mechanisms other than, we should talk offline.
Yeah, the requirement. Yeah,
the requirement that you have can be met with the mechanics that exist in segment routing. Yeah. So maybe we will happy to talk a bit more offline.
Yeah,
that sounds good.
Yeah, we can also do it on the list.
Robin Huawei, I wanted to add some this clarification. So the first is the resource reservation. I think now the SR mechanism that is always to do the bandwidth admission control in the PCE controller, but there's no actual bandwidth guarantee in the forwarding plane. So this is the method explained here is not only for the bandwidth admission control, but also the bandwidth reservation in the forwarding plane. This is the first point. The second point, I think that regarding the Ketan's the comments, because I think the MPR's TE, RSVP TE at that time, it can do the resource reservation, but in fact, it's not explained how to implement the resource reservation. But everyone understands it will be done in the data plane. So I think this may be the similar definition or description for this draft. So that is my...
Okay, then we don't have time. Thank you, Robin.
Okay.
Thank you, G.
Yeah.
So
we have one more slide. I think.
we over time already.
Okay, people can take a look. I
Yes,
think.
please.
Thank you.
Thank you, G. Thank you for your time. Have a good trip back home. Thank you. And see you in Toronto. Montreal.
So. To you.